Okay, we're going to look at some of the homework problems in section 4.3. I will start with number 1, where you're finding the greatest common divisor and the least common multiple of the following using the intersection of sets method. And we're going to start with part A, which is 175 and 14. So we're going to find the greatest common divisor of 175 and 14. And that's using the intersection of sets method. So in this case here, we're looking for the divisors of 175, and I've already know what they are. They're going to be these numbers: 1, 5, 7, 25, 35, and 175. Those are the divisors of 175. Now for the divisors of 14, they're going to be 1, 2, 7, and 14, because those are the numbers that would give me a product of 175. Think of this: for 175, it'll be 1 times 75, 5 times 35, 7 times 25. For 14, I have 1 times 14, 2 times 7. Okay, now I want to match up all the common divisors that are in both of these sets. You can see there's a 1 in both of these sets. There's also 7 in both of these sets. But we want the greatest common divisor. And the greatest one that's in both 175 and 14 would be 7. So the greatest common divisor of 175 and 14 would be 7. Okay. Now we want the LCM, or the least common multiple of 175 and 14. So what we want are the multiples of 175 and the multiples of 14. Okay, now for 175, we start with 175 and then just increase each time. So here by 175, so 175, the next one will be 350, and then the next one will be 525, the next one will be 700, and it'll continue on and on and on. Now for 14, since it's a small number, it's going to continue for quite a while. So here you're going to have 14, then 28, 42, 56, 70, and then 84, 98, 112, 126, 140, then 154, and then after that will be 168, 182, 196, and then you got 210, and then add 14 more, you get 224, 14 more will be 236, no, 238, I'm sorry. 14 more will be 252, another 14 will be 266, another 14 more will be 280, then 294, then 308, then 322, 336, and 350. And I will stop at 350 because I see that 350 is the lowest multiple that's in both 175 and 14. So the least common multiple for 175 and 14 would be 350. Okay. Okay, now let's look at part B. Here we want to find the GCD of 1,715 and 1,225. Okay, so here we want the GCD of 1715 and 1225 using the intersection of sets methods. So the divisors of 1715 will be 1, 5, 7, 35, 49, 245, 343, 1715. Okay. Now these may not be all of them, but those are some of the divisors of 1715 that I could come up with. Now for 1225, it'll be 1, 5, 7, 25, 35, 49, 175, 245, 1225. Okay. Now again, we match up our common factors. Of course, 1 is in both of these sets, so is the 5, so is 7, and so is 35. But as you can see here, 35 is the small, and also 245, I'm sorry. I left that out. You can see that 245 is the smallest that's in both of the divisors, well, both 1715 and 225. So 245 is the greatest common divisor for 1715 and 1225. Okay, now using the intersection of sets methods, I'm going to find the least common multiple of those two numbers. So here we want the multiples of 1715. So in this case here, you may have to use a calculator if you have to. So the next multiple will be 3430. And then the next one would be 5145. And then the next one would be 6,860. And then the next one will be 8,575. And this will continue on and on and on. Now for the multiples of 1225, I'll start with 1,225, and then 2,450, okay, and then add another 1225, which will be 3675, plus another 1225 will be 4,900, plus another 1225 will be 6125, and then another 1225 will be 7350, and then another 1225 will be 8575. But I will stop at 8575 because if you notice, 8575 is in both of these sets, as you can see here and here. So I can conclude that the least common multiple for 1715 and 1225 will be 8,575. Okay. Okay, now let's look at the next problem. We're finding the LCM and the GCD of 156 and 504, but we have to use the prime factorization method. Okay, so we're going to do a prime factorization for 156 and 504. Okay, we want two numbers that will give me a product of 156. We'll start with that one. We know 2 is divisible by 156, so if I pull out the 2 and divide 2 into 156, that's going to give me 78. And I know 2 is prime. 78 is divisible by 2, so I can pull out the 2. 2 into 78, that'll go 39 times. And 2 is prime. Now I must use 3. So I divide 3 into 39, that's going to be 13. And 13 is prime. So 156 as a prime factorization, and I'll write this off to the side, it's going to be 2 to the second times 3 times 13. Now for the number 504, I can use 2. Divide 2 into 504, that's going to be 252. 252 is again divisible by 2, so let's use 2 again. And divide 2 into 252, that's going to go 126 or 176. No, 126, I was right. Okay, and 126 is divisible by 2, so we use that again. That's going to go 63 times. And then 63 can be broken up into 9 times 7. And I know 7 is prime. And then 9 can be broken up into 3 times 3. Okay, so that's the prime factorization of 504, which is in this case 2 to the third times 3 to the second times 7. So those are my two prime factorizations here. Now here I want the LCM. Okay, now for the LCM, when you're doing the prime factorization method, you must use the each prime number, the greatest number of times that it occurs in any one of those factorizations. In this case, we got to use the 2, but we want to use the largest exponent for 2, which is 3, so it'll be 2 to the third. The 3, we're going to use the largest exponent for 3, that's 3 to the second, then times 7, because it occurs in either one of the two factorizations, and then the 13, because it occurs in either one of the two factorizations. So in this case here, if you do 2 to the third power times 3 to the second times 7 times 13, just multiply all that out, you'll get 6,552. So the least common multiple is 6,552. Okay, now we want the greatest common divisor, or the GCD. Okay, we use the common factor that's in both of these factorizations, and we use the one with the lowest exponent. The 2 is in both of these, but we use the lowest exponent for the 2, which is 2, so it'll be 2 to the second. The 3 is in both 156 and 504. We use the lowest exponent for the 3, which is 1, so it'll be 3 to the 1. We can't use the 13 because it's not in both of these, and we can't use the 7 because it's not in both of the factorizations. So it's just 2 to the second times 3. Multiply that out, you're going to get 12. So the greatest common divisor of 156 and 504 would be 12. Okay, next problem is using the Euclidean algorithm to find the GCD for 633 and 7,611. Okay, so here we're going to use the Euclidean algorithm for this particular problem. What I'm going to do is divide the lowest number into the highest number. So we got 663 divided into 7,611. Okay, the larger number is divided by the smaller number. And then we're going to use long division in this case. We will continue the process until the remainder is 0. If that remainder is 0, then the last divisor of that GCD will be your GCD of those two numbers here. Let's divide 663 into 7,611. That's going to go, well, 6 into 761 is going to go one time. 1 times 663 is 663. 663 from 761, this will be 8. That'd be 9. Bring down the 1. And then we divide 663 into 981. That's going to go one time. 1 times 663 is 663. So subtract, this will be, this gives me a remainder of 318, which is not a remainder of 0. So what I'm going to do here is take the last divisor, which is 663, and divide that by the remainder of 318. So this will be, that 318 will be your divisor. Your old divisor will be your dividend. So now I have 318 into 663. So when I divide 318 into 663, that's going to go 2 times. So divide 2 times 318, that's going to give me 636. 636 from 318 would give me 27. So here, the remainder is not 0, so we'll continue this process by dividing this remainder into this old divisor. So now you're going to have 27 divided into 318. Okay, so now 27 into 318 will go one time. So 1 times 27 will be 27. From 31 will be 4. Bring down the 8. Divide 27 into 48. That's going to go one time. 1 times 1 times 27 is 27. 27 from 48 will be 21. Again, that's not 0. So we divide the last divisor by the remainder. In this case, 21 into 27. Well, 21 goes into 27 one time. 1 times 21 is 21. And that will leave me with 6. Again, it's not 0, so 6 into 21 is what I will do here in this case. So 6 goes into 21 3 times. 3 times 6 is 18. 18 minus 18 from 21 will give me 3. Still not 0, so I'll divide this 3 into 6. 3 goes into 6 2 times. 3 times 2 is 6. Now I have a 0 remainder. That last divisor that I used here is 3. So that tells me that the GCD of 663 and 7611 is 3. So the greatest common divisor is 3 in this particular situation. And that's using the Euclidean algorithm. All right, the next problem. Here we want to find the LCM of this set of numbers and do so mentally, if at all possible. So we got 35, 175, and 245. the least common multiple of this set of numbers. Okay, if I do 35 as the list of multiples, let's see, this will be 35, 70, 105, 140, 175. Okay. Well, I know for 35 and 175, the least common multiple will have to be 175. So now let's do 175 and 245. Okay. And whatever the least common multiple of 175 and 245 would be, is going to be the least common multiple for 35. Okay. Because for 35 and 75, that least number is 175. So in this case here, we'll start with 175, 350, and then 525, 700, 875, 1050, and then 1225, and this continues on and on and on. Now for 245, we'll start with 245. This one will be 490. The next one will be 735. The next one will be 980. And then the next one will be 1225. And notice 1225 is in both 175 and 245. So the least common multiple for 35, 175, and 245 will have to be 1225. Okay. All right, the next problem is an application that deals with some of the greatest common divisor problems and the least common multiple problems. In this case here, Calvin has 3 alarm clocks which sound at different intervals. Clock A goes off every 30 minutes, clock B goes off every 35 minutes, and clock C every 40 minutes. The 3 clocks sound together every how many minutes? This one is an application of the least common multiple. So we want the LCM of 30, 35, and 40. So let's start with 30 and 35. Because that's 30, that's going to be 60, 90, 120, 150, 180, 210, 240, 270. Or better yet, let's do 35 and 40, because this might be a little bit time consuming here in this case here. Let's see, 40, 80, 120, 160, 200, 240. Well, we know 240 is the least common multiple for 30 and 40. Or we can say 120 is the least common multiple here for 30 and 40. Okay, so we can start with 120 and 35, which will be 240, and then 360, then 480, 600, 720, 840. But for 35, you know, this is going to be quite a long one. This one will be 70, 105, 140, 175, 210, 240, 245, 270, no, 280, I'm sorry. And then 315, 350, 385, 420. But it's going to go on up to 840 if you were to continue this, because 840 would be the least common multiple of that. Okay, so the 3 clocks will sound together every 840 minutes. Okay, because there are ways that you can come up with the least common multiple here. Because you can do 30 and 35 and try to come up with the least common multiple, which of course, which I know that's 210. And then 210 and 40, you can try to come up with the least common multiple as well. So it'll end up being 840. All right, problem number 6. Midas has 24 silver coins and 36 gold coins. He wants to place his gold coins and his silver coins in stacks so that there are the same number of coins in each stack. What is the greatest number of coins that he can place in each stack? Okay, that's the greatest common factor type problem here. And in this case here, there are ways that you can do this. You can do prime factorization or intersection of sets, but I'll do prime factorization here because this will be 2 times 12, then this will be 2 times 6, then 2 times 3. So this will be 2 to the 3rd times 3, and then for the number 36, that's 2 times 18, 2 times 9, 3 times 3. So this will be 2 to the 2nd times 3 to the 2nd. In this case here, we want to use the common factor that has the lowest exponent. 2 is the common factor in both of these. So here, this will be 2 to the 2nd. We want the lowest exponent. And then the 3 is common in both. We want the lowest exponent for 3, which is the 3 to the 1st power. So this will equal 2 to the 2nd, which is 4 times 3, which is 12. And that's your greatest common divisor. So the greatest number of coins that can be used here is 12. Alright, the next problem. The hardware store sells bolts in packages of 4, nuts in packages of 6, and washers in packages of 5. What is the least number of bolts, nuts, and washers that can be purchased so that there's an equal number of each? Okay, so here, this is one of the least common multiple type problems. 4, 6, and 5. And these are small numbers that we can use here with this. Because with 4, we got 4, then 8, 12, 16, 20. Now with 5, that's going to be 5, 10, 15, 20. Now I know 20 is going to be the least common multiple of 4 and 5. Or, probably the better way is using a prime factorization. 4 is going to be 2 times 2. 6 will be 2 times 3. 5 will be just 5. And then for the least common multiple, we use each individual factor the greatest number of times. The 2 is going to be used twice. So with the 3 will be used once, and the 5 will be used once. So 2 squared, that's 4 times 3 is 5 times 5. 2 to the 2nd is 4 times 3 is 12. Times 5 is 60. So the least common multiple is 60. So the purchase must include at least 60 each of the bolts, nuts, and washers. Okay? And then finally, a new bookstore gave a 30% discount every 35th and 36th customer to enter on a certain day, and a free book every 170 to every 175th. The first to receive both the discount and the book was to what customer? I see 35 and 36 are consecutive numbers, so in this case here, we find the least common multiple here. And that's going to be, in this case here, the 175th customer. Okay, because with that 35, the 35th customer, if you extend this out, this will be 70, and then 105, and then 140, then 175. Okay, because at the 175th customer, he's going to get the discount and the free book. Okay, so the first person that receives the discount and the book will be the 175th customer. Okay, so this should be enough to assist you with the homework in section 4.3.